Hi, Lou here to discuss briefly numbers and probability and averages, because these topics are important to game designers. No, not all games are math, although puzzles are often all math. But numbers are frequently part of games, if only in the background, as probabilities. Many game players are close to enumerate these days, but that doesn't change the math in the game. Someone who doesn't understand the distribution of 2d6 is at a great disadvantage in a game as simple as Settlers of Catan, because they don't understand that a 7 is much more likely to occur than a 2 when you roll 2 dice and add the sum together. Game designers have to understand probability, different kinds of averages, the difference between 1 in 1,000 and 1 in a million, because a lot of people don't. 1,000 days amounts to how many years? Well, about 3. A million days? About 3,000. A lot of people don't get that 1 in 1,000 is something that might actually occur in their lifetime, but 1 in a million probably won't. Now, the best discussion of probability I know of is by James Ernest, who's designed many games. It's an article called Probability for Game Designers at the League of Game Makers. Much of what I am going to talk about in the following is derived from my book, Game Design: How to Create Video and Tabletop Games Start to Finish, published in 2012. Now, some of the following may be very simple for technical people, such as programmers, but for your average person, it isn't. Try it and see. First, we have the odds question. What are the odds for particular sums when you roll 2 normal dice and add the result? So few people understand that when I bought a copy of Settlers of Catan to find out what it was all about, the US edition included a table that showed those chances. The result is what's called the normal or Gaussian or bell curve. And I have a diagram that will show you the bell in a minute. You can figure this out, because it's relatively simple, by listing all 36 possible combinations of the results of 2 dice rolls. Keep in mind, a 1 and a 2 is separate from a 2 and a 1. And here's a summary of that. So you have 1 chance in 12 of rolling a 4. You have 1 chance in 6 of rolling a 7. There are 6 chances in 36, or 1 in 6, of rolling a 10 or higher. So you have the same chance of rolling a 10 or higher on 2 dice as you do of rolling a 6 on 1 die. And we have that same chance for rolling a 4 or lower. The same chance, again, 6 and 36, to roll exactly a 7. You can make a table showing all 36 possible rolls. I haven't included one here. Here is a simple example of a bell curve. Now, next we're going to talk about averages, because there are actually 3 kinds of averages that are commonly used. I'm sure there's more that I don't know about. The most common one is the mean, which is often just called average. When somebody says average and they don't say otherwise, they probably mean the mean. The mean is calculated by adding all the numbers up that you've got and dividing by the number of data points. The total of the numbers divided by the number of numbers. Now, the problem with this is it can result in skewed numbers that misrepresent a situation. For example, the median of the numbers 42, 5, 5, and 3, and 2 is 11.4. So you could say the average is 11.4, and that might sound pretty good, if high is good, until you know that 4 of the 5 numbers are less than half the mean. So the median is a better way of looking at this, because the median here is 5. The median is the middle number, the middle data point. So the second 5 is the median. This avoids the outliers, the numbers that can skew things, like 42. It's a hidden average that often illuminates a situation better. Here's an example in games. The median income for a mobile game on Apple's store is $6,000. You add all the incomes up and divide by the number of games. But the mean is more like $500 because the median is skewed by the enormously successful games like Clash of Clans and Angry Birds. What's the more meaningful number? $500 is a more meaningful number for most people who are thinking about developing a mobile game. They're not going to make $6,000, they're going to make closer to $500. That's where the median is so useful and so important compared to the mean. Now we also have a third kind of average, the mode. This isn't used much in normal discourse, but scientists find it useful. The mode is simply the most common data point. In our example of 5 numbers, it happens to be 5, which is the same as the median, but that's not always the case. For example, if you take the numbers 8, 7, 6, 5, 4, 4, 2, the mode is 4, even though the median is 5. So you won't use the mode much, but the median is very important.